Hello and welcome to The Most Significant Bit, a podcast exploring the connections between engineering, technology, humanities, and the arts. I am Ty Cronin, and today we are discussing biomimicry involving impact resistance. In this episode, I will discuss how some researchers and engineers took features and aspects from the head of a woodpecker and revolutionized impact resistance. To begin, the team studied the structure of the woodpecker's head. The team pulled four main structures from the head of said woodpeckers. Number 1, the beak. Number 2, a spongy bone in the front of the skull. Number 3, the hyoid. And number 4, the skull and the fluid inside the skull. Now, let's dive into each of these structures. Number 1, the beak. The beak of the woodpecker is relatively large compared to its body. This helps to disperse the energy from the impact throughout its whole head. The beak is also made up from an elastic material which helps dampen vibrations. Next, the spongy bone. The spongy bone is part of the skull, but it is located just above the eye sockets. This bone is dense but still spongy compared to the rest of the skull. This bone is thought to evenly disperse pressure before propagating to the brain. Now to the hyoid. The hyoid extends from the base of the tongue back past the throat and the spine, then up and around the top of the skull, ending at the nostrils. The hyoid is used to extend the tongue into the beak and bypass energy through itself and up and around the skull. And finally, the skull bone. The skull bone is very close to the brain. This leaves little room for fluid around the brain. This once again helps dampen vibration and absorbs energy. These are the four structures the team singled out. From these structures, the team developed a system that mimicked the principles these structures utilized in the woodpecker's head. Now, time to dive into the system that was created. The overall system is cylinder in shape and made of layers. The first layer is a hard steel outer casing. This layer acts like the beak of the woodpecker. It is the first point of impact and distributes the force throughout the whole cylinder. Next is a semi-elastic layer. This layer acts like the hyoid. Like the hyoid, it dampens vibrations and helps with force distribution. The third layer is a layer of aluminum. The layer of aluminum acts like the spongy bone in the skull of the woodpecker. This aluminum, being softer than the steel, allows for a sort of crush zone, in case the contents inside become displaced. And finally, the rest of the empty space on the inside of the cylinder is filled with small glass beads, and the device or piece to be protected is placed in the middle of these beads. These beads act like the skull and fluid around the brain of the woodpecker. If any of the force makes its way to this point, the beads help to dissipate it and prevent it from harming the device. These four layers combined come together to act like the head of the wood structure, mimicking the structures inside. Once the team had physical structures built, they used a 60mm smoothbore airgun to test their system. They fired the cylinders out of the airgun and into a solid wall. When testing was concluded, they had a failure rate of only 0.7% and were able to protect devices from up to 60,000 Gs. This was a drastic decrease in failure rate when compared to using hard resin methods that was in use at the time, with a failure rate of 26.4%. Today we covered how a team took inspiration from nature to advance the systems we use to absorb impacts. Why try to reinvent the wheel when nature has already developed a solution? The real challenge that faces us today is finding a way to apply what we see in nature to the problems we encounter. Thanks for listening.